everyone. Welcome to Techno Days, another session. And today's session is on malware analysis. So, basically, I'll be talking about exploring the technical aspects of malware in a very simpler way, which I am calling right now as a non technical way. And so, let's get started. So before moving ahead, I would like to start with, introducing about myself. So I work at Qualys as a web application security analyst, and I am the vice chair and technical lead at BBWIC Foundation, which is Breaking Barriers Women in Cybersecurity. I'm also one of the Google developer expert from India on web technologies, and I'm also a mentor at Cyber Preserve and at BAP Infosec. I'm one of the committee member at OWASP FIA and also technical blogger and have been speaker and trainer at various conferences like OWASP Foundation, OWASP Seasides, RootConf, KuCon, etc. So, for today's session, the agenda is very simple. We'll be talking about the simplest of the things about malware, and we don't have to have any, technical background related to malware. I'm just focusing it for the beginners who want to get their career started into malware research or malware analysis, or someone who is very interested in into malware analysis. So today's agenda is understanding what malware is, why are we infected with malware, why are we talking about malware, what could be the impacts of malware, the types of malware, their analysis, some real world examples that we'll be talking about. I'll give you some demo examples. I won't be showing an entire demo, but yes, I would give you some demo that examples that I had performed before. And finally, we'll be talking about the prevention and conclusion. So let's get started. So what is malware? So thinking about malware, one thing that comes into our mind is like virus, worms, how our system gets affected, and we are very much sure of like whenever something happens to our system, we often use the term like maybe my system has got affected by malware or by a virus. So malware is anything like it could be a software. Everything over the internet, everything that your device is using, is actually a piece of code. And when some kind of suspicious activity your code performs, it becomes malicious, of course. So at that point of time, we call it malware. So malware is a combination or a conjunction of two words, malicious software. So when there is a software, when there's a piece of code or there's a program whose intent is to disrupt some of your services in your system or maybe steal your data or any kind of any malicious activity that it wants to perform, then we call it a malware. And hence, what could be malware analysis? Analyzing that particular malware, that malicious software, is malware analysis. So we are examining that particular software that we think that it could be a suspicious one, or maybe it is performing some kind of activity that it is not supposed to be, or a software is not supposed to do. So at that point of time, while we are examining a malicious software, we call it malware analysis. So the next thing, what are we actually trying to analyze in malware analysis? So getting back to the previous slide before moving ahead, I would like to mention few things. Like as I said, like a software, a piece of code, when it is performing some kind of malicious activity, we are calling it a malware. So what do we look for even while building a software or while we are writing a simpler program? We do look for the file type. We are looking for certain things like what kind of program it would be, or what kind of file it could be, what kind of software it could be, what kind of language is it based on. For example, are we trying to write a code, or if it is a software based on maybe cpp, c++, or maybe simpler python program, or maybe some other kind of binaries. Of course, it would be also based on some other kind of languages. So we are detecting, we are analyzing these kinds of things. First of all, we are thinking what the file type could be, Is it a PDF or is it a document or it is an Excel, PowerPoint? What kind of file it could be? What kind of language it could be based on? If it is a programming language, like, or it is just a piece of code, then it is Python based, it is it C++ based, or it is just a normal batch script or bash script? We don't know. So we'll try to analyze what it could be. Platform dependency. Now, there are certain files, there are certain softwares which are dependent on a platform. For example, the exe files. These files are executable, these are Windows executable. Most of the users worldwide are Windows users. Like, it is more friendly, user friendly, as we say. So in Windows, most of the programs or most of the softwares are exe based. So they are platform dependent. A .exe file, .exe would be the extension. A .exe file would not be running on a Linux machine or any other kind of software or Unix based software. It is totally based on Windows based, or it is made for running it in a Windows environment and nothing else, nowhere else. The next thing is intention of the software. Every kind of software, since we are analyzing a malicious software, a malicious program, so every kind of malicious software has an intention. So while analyzing, we are trying to figure out what the intention of that particular software could be. Is it trying to steal your data? Or is it just trying to, eat up all your RAM? Or maybe it is just trying to, connect to other networks or some other kind of targets. And there are a lot more. Other than all these things, we try to look for timestamps, we try to look for use authors names, we try to look for strings, different kind of strings like URLs, links, all these kinds of things we try to look for, which I'm not mentioning right now. We'll be discussing about these things, and we don't have to get into those things as of now. For a beginner, we just need to understand, like, what are we trying to figure out while analyzing a software, analyzing a malicious software. But all of these things are very important because these ultimately help you to understand who could be the threat actor. What do I mean by the threat actor? A threat actor could be a group of organization, a group of people, a group of hackers who are targeting a particular organization, or maybe just simply performing this attack, this malware based attack. So we are trying to figure it out, because after analyzing a malware, we are trying to know who has done this, with what intention that particular organization must have initiated this attack. So we are looking for all these kinds of answers. But why? I already given have given the answer to this question, like, why. The first could be to examine the nature of the malware. So once you understand what the nature of the malware is, it helps us to understand how the system got compromised. Like, for example, if the malware, how did the malware infect the system? Did it come through, an email? We all know what email could be. We know what our spam emails contain. They have a number of attachments. They have a number of links. Even on those emails, if there is a link, did you click on the link? Did the virus, or sorry, did the malware got downloaded from that particular link? Or did that malware got infected into your system through the attachment? You downloaded the attachment, you executed the attachment, you opened the attachment, and it got executed in your system. So we try to examine what the nature of the malware could be, because that helps you to understand what file type it is showing, but what file type it actually is. And the next thing is what kind of platform it is actually based on. As I mentioned, most of the time the target audience is Windows based. So a lot of times you will see these attachments are, or the links are downloading a .exe file or other kind of executables, Windows-based executable files, but their extension could be different. For example, it is a .exe file, as I mentioned before, but they have set an extension such as .pdf. So you would think of it as a PDF file, but it was actually an exe file which is getting executed in your system. A normal user might be unaware of this fact. Also, the next thing that you would try to understand, if the attack is targeted. A lot of times, in very infamous malware attacks are targeted. They target a specific kind of organization, maybe a healthcare organization, or maybe some other kind of government institutes. So they are completely targeted a lot of times. For what reasons? Like they would either be stealing the data, or maybe they just want to sell their data into the dark web. So they have different motives behind performing these kinds of attacks, and these attacks are very smooth. They start, they have a lot of planning and plotting for performing these kinds of attacks. The next thing is, excuse me, the next thing is to understand if the attack has actually affected the network. Now, sometimes the malware do not infect the entire network, but a lot of times the malware is intended to affect the entire network. So it is always suggested, like whenever you realize, or whenever an individual or an organization feels that their system, their device, the components have been affected or infected from a malware, they should disconnect those particular devices from the network, so that they could stop the spread of that particular malware to other into other devices. So these things also help you to understand. A lot of times there could be systems, there could be devices which have been infected and you are not aware of, and there are plenty of such examples. The organizations would be unaware of the malware that had been residing in their system for a number of months, and later they figure out, when they see some kind of suspicious activity, or some kind of suspicious activity is getting logged into the system, into the scanners or whichever devices they're using. So if in that case it gets detected over there, at that point of time they realize, and then they start analyzing those malicious software and start understanding, okay, it had been there and it got affected through the network. So for example, if an organization, suppose a device got infected with malware initially and it did not disconnected from the network, the malware would have infected the entire system, but they are not detected at that point of time. But few of the systems just got detected, and this is still dangerous. Of course, even a single device getting infected in a huge organization can cost a lot. Another thing could be, like, the malware's intention could be to extract excuse me, information from different files, from different registry keys, from different logs. What are all these things? These are some important files which are present in the operating system that actually help in the functioning of the operating system. Talking about the registry keys, there are other logs which are related to what kind of usage, how the system is being used, for what reason the system is being used. There could be some files which are confidential, and the users are not supposed, I mean a third person is not supposed to view them. Or of course, if the data is confidential, it has to be within the organization only. So at that point of time, such malware attacks intention is to infect those files, and if they don't if if they can't infect the files, they would try to steal those files, steal those data, and then might try to um, maybe blackmail them, or maybe sell the data into the dark web. They can perform a lot of things. They have a lot of ideas. They have a lot of intentions, bad intentions, for performing all these kinds of attacks. Again, to comprehend the motive of the attacks, in the above few points, we actually try to figure out what could be the motive of the attackers. For example, are they trying to just target the organization? They are just targeting for stealing data, or stealing some kind of money from them, or maybe they just want to blackmail them into paying some kind of ransom to them. We all have heard about such kind of attacks, right? We have heard about how ransomware, we'll be discussing a bit about ransomware as well. So how these attacks are being performed? So the attackers actually target these organizations based on what they can be, what the attackers could be offered from them. For example, sometimes the malware attack is just for stealing some sensitive information, for stealing some PII data, personal identifiable information. For example, credit card details, debit card details, these kinds of sensitive informations. Sometimes these attacks are performed just to steal those data, again, those PII data, and sell them over the dark web. Sometimes they are just used for stealing money out of their accounts. Sometimes those attackers are asked to target an organization because so that they can disrupt the services or disrupt the entire organization in a very different way, in a very because nowadays everything runs on internet. Cyber is the new world. We can call it a new cyber world where we all are linked through internet. So if anything, any disruption happens in an organization, it is a huge loss. So sometimes it is a target attack for to an organization, at an organization, sorry. So, what could be the impact? In that case, what could be the impact? Again, we discussed a lot about it right now. Like sometimes they steal some sensitive information. Sometimes they would steal those sensitive information either for their own usage, or maybe they would sell them somewhere. Sometimes they slow down your system. Initially, in the very beginning, when malwares were not that famous. For example, like in the early times when we just some devices got came into picture, like the first computer came into picture, the first programming language. At that point of time, the malwares were just created for slowing down your system. Just they wanted to see how the program runs. If we try to perform these kinds of activity with this particular program, what would happen? So nowadays, most of the time, I don't. There are very few malware which are intended just for slowing down your system. But yes, slowing down your system could be one of the way of detecting if your system is affected from a malware. Restricted access, maybe you are an admin to a server, to your server, to a database server, and the attackers have actually infected your system, hence your database, and they have restricted your access from the database, hence disrupting or taking away all the data from the database and disrupting all other kinds of authorized access. So they can perform these kinds of activities as well. Spreading across the network, as I mentioned, if your system is getting infected, if your device is getting infected from a malware, it is very important to disconnect it from the network, because there are very high chances that this way, through the network, the malware would get infected into other systems as well, or other devices as well, and disrupt daily operations. How would your daily operations be disrupted? For example, you're working on your system, you are unaware of the fact that your system is infected with a malware, and your system just slows down. So it disrupts some of your work, because if it is slowing down, you won't be able to do your work as smoothly as possible. You you have logged into your account details, to your bank account details, maybe your email addresses, your other kinds of social media links are present. You have already saved all your passwords over there, and you're unaware of the fact that your system is infected and it is actually stealing those information. So this is how a malware actually impacts a system, and of course, all these steps lead to disrupting the entire organization if it gets infected with even a very small malware. And also, the above impact gives you an idea on what a malware attack symptoms could be. So, if your system is getting affected, or if you're observing that these kinds of things are happening in your system, it is very important to check, to scan your system, or maybe have a look at what is happening. Is your system really getting slow, or are you really performing that much amount of work, or is it really affected from a virus? Like, for example, you're having 8 GB RAM memory in your Windows system, and the only thing that you're doing is you have opened a document, Word document, and you're just writing some kind of article into it. And you suddenly see that your system is hanging, a lot of activities are getting performed. You may seriously may use task manager, or task manager is one utility from where you can actually see what all the processes running in your system. So from there, you may come to know about what is happening actually. So even if you can't open that, this is a very simplest thing, that just running or using one single application should not lead your system to, should not lead to the slowing down of your system, provided your system is having such amount of RAM, like 8 GB of RAM is really good, and it should, a simple work document should be working very properly. And if it is not, it is very important to scan your system, have a look at what is happening. This is this does not necessarily mean that every time if it is happening, then this could be the only reason. This could be one of the reason. It's never bad, or it's never, yeah, it is never bad to be aware of all such things. Now, what should you do in a malware attack? One thing that I've been mentioning since beginning is disconnect your system from the network. It is very important so that you can prevent the spread of that particular malicious software to other devices. Again, if you see that your system is being infected from a malware, you have to perform a thorough scan of that unusual behavior. You have to figure out what kind of unusual behavior are you observing, and if yes, there is an unusual behavior, scan your system, use some anti-malware devices so that you can remove that from your devices. Detect other affected systems or devices. Even though you suppose you disconnected your system from the network, there's a very high scope that it may have infected some other network. So there's no harm in checking what if it would have if it had infected any other systems. So it is always better to be aware. It is always good to know what is happening. It's always better to be aware of the surroundings, of your surroundings, of the systems that are present in your surrounding. Always keep a backup of your files, so just in case you lose your data, so you will have a backup of those files, and you don't have to be, you don't have to panic much. These are just some precautions that you always need to take care of. Call your incident response team. Now, for example, you are in an organization, and your organization suffered from some kind of malware attack. So, of course, the very first team that is supposed to work on this and figure out what has happened is the incident response team. So, contact them, let them know if you have observed some kind of unusual activity, let them know, let them analyze, and later they can help you figure out how to remove those malicious activity or the malicious program from your system. Are types of malware. Of course, I won't be explaining each and everything in detail, but yes, I'll give you some ideas of what this could be. See, these are not the only types of malware. There are a lot of malwares out there. Each of them are defined on the basis of the work they perform. For example, ransomware. We have heard about ransomware a lot. So, what do they do? It's kind of malicious software which is performing some kind of disruption in your system, and in return it is asking for some ransom. So most of the ransomware that we have come across, and a larger of that particular kind, try to encrypt all your files. They encrypt all the files in your system, in your device, and then they ask for some amount as a ransom from you, and in return they would give you the key so that you can decrypt those files. Now they ask for the amount in bitcoins or maybe some other kind of cryptocurrency because they are anonymous and decentralized, and they have other reasons as well. So this is one example how ransomware works. This is how actually ransomware works. So spyware is another where it is spying on you. Adware, Trojans, worms, rootkits, keyloggers. Keyloggers are the kind of malware who would, uh, detect your keystrokes and then save them, and this would help them detecting your password and then hence performing some other kind of malicious activity. So these are some of the types of malware. There are a lot of them. I've not mentioned all of them, and of course I've mentioned very few. I've explained very few of them just to give you an example. Like, these are how they are defined, what kind of activity they are performing. For example, as I mentioned, keyloggers are saving your keystrokes, they're detecting your keystrokes. Ransomware is stealing, ransomware is actually encrypting your files, and in return, it is asking for a ransom. Spyware is, spying on you. Trojans are getting hidden behind some legitimate software. So these are some of the ways how different types of malwares are defined, and based on that the analysis is further performed. As we mentioned, that we try to understand what kind of malware is it, what is the nature of the malware. Like, if it is a ransomware, we can easily understand that it is asking for some money. What it has done, if it has encrypted your files, the first thing that you need to understand is whether you have kept a backup of the files. As we had mentioned before, keeping a backup of your files are very important. So moving ahead, some malware analysis techniques. So static and dynamic analysis are the two most important ones. Of course, there are other ways also, like memory analysis, behavior analysis, and these somewhere come within them only. They may slightly differ, they may slightly look the same. So, static, as the term static suggests, it means that you're analyzing a malware without running it. What do I mean by without running it? I am not executing that malware. I have that particular malware.exe file, say. So, what I would do is I would use different kinds of tools to figure out what is present within that particular malicious software. So there are tools which actually break down the binary, and you can see some language code. You would be using disassembler in that case, which is actually helping you to analyze what is happening within it. Sometimes you try to figure out what kind of strings have been used. What do I mean by strings? The URLs, the links, something which is very easily readable by us. Like, we can easily analyze, okay, there is some kind of URL present, so maybe it is trying to contact that URL. There's some kind of IP address, or maybe there is a file that it is trying to access. We can also read those files through strings. We may try to, analyze, we may try to study who the author could be or the timestamp. You never know what kind of details as strings would come while analyzing that, while statically analyzing it. Virus Total is one platform where you can upload the hash, or maybe just upload that particular malicious file. Uploading a hash is always a better idea because you may always change the file name. What do I mean by hash? Hash is a one-way function. It is unique for every kind of, every string, or maybe for if you have some data. If I may try to explain it in a layman's language, if there is some kind of data or maybe some kind of information, creating a hash of that particular data gives an output which is called a hash. And if you make any simple change within that particular statement or particular information, for example, you just changed one character from that particular information, the entire hash would change. So a hash is unique to each unique string. Two same strings would provide two similar hash. So a hash helps to, in helps a lot in such scenarios, because every string has its unique hash. So a malware, even though the file name might be changed, but the details or the information present within it, or the piece of code present within it, would not be very different. So in that case, uploading a hash in virus total, that particular platform, would help you understand, like, if it is actually a malware, has any other antivirus or any other anti malware software detected it before. Because virus total works on the basis of a number of scanners which have previously detected, which may or may not have previously detected that particular malware. So it gives you a result, and based on the result, you can actually comprehend if it is if the mal if that particular file is malicious or not. So these are some ways how you try to analyze if that particular file is malicious. In dynamic analysis, as the term suggests, you are examining that particular malware while executing it. So you run that malware, which is a very risky thing. So you run that malware, and then you start analyzing what is it trying to do. Static analysis provides you a path to dynamic analysis. You gain a lot of information from static analysis. You understand, like, what kind of strings it might have used, the urls it has tried connecting to. You would see all those things, maybe some kind of libraries that it tried connecting, it contacting to, or maybe it tried calling. What do I mean? What I mean to say is the kind of functions or the DLL files that it is trying to connect to. So in dynamic analysis, we would be actually seeing at what particular point of time a function is being called or a library is being called. These libraries, in case of Windows, are DLL, dynamic libraries, basically what we call them. So these are very important for any kind of programs that you're running. If you analyze, deassemble any piece of code, not specifically malware, you would see that how they are calling different functions, different DLL files in that case. So, studying a malware while it is running helps you to connect the dots, connect those information that you collected from static analysis. Also, dynamic analysis give you more idea about what is happening, how is it running, what is it trying to, when is it trying to connect to another IP, when is it trying to perform that particular call. So in dynamic analysis, you make uses of virtual machines. I'll explain what virtual machine is. You make use of some sandboxes. You try to you use a number of tools like Wireshark. For example, in static analysis, as I mentioned, virus total is one. Strings is one command line tool. You can use a number of disassembler as well. In dynamic analysis, you take snapshots. Also, I'll explain what snapshots mean. So, as I mentioned, what do you need for performing an entire static and dynamic analysis? So, the first thing is VM, virtual machine. So, you cannot run or analyze a malware into your host machine, in your actual operating system that you're working on. You should not be doing that. Even if you're performing static analysis, you should not. Although in static analysis, you're not running that software, but it is recommended because you never know what if you double click on it and it ends up running. Of course, we do take all kinds of precautions, so not so that we do not run it unnecessarily or when it is not required, but it is always better to be on the safer side. That's why we have virtual machines, we have sandbox environment. What is a virtual machine? Is like it is a kind of different environment, operating system based environment, where you can actually run your malware. Virtual machines are used for a various of reasons, but for malware analysis, you create an entire environment of yourself. For example, if you want to run that malware, you would create a victim virtual machine, for example, Windows. So that virtual machine, in that virtual machine, if you run that malware, it will not infect your system. It will not infect your actual machine. And you may delete the system later. Now, if the virtual machine is not infected with the malware yet, so before performing malware analysis, you may take a snapshot. So, what does a snapshot do after infecting your system? You may click on this, you can get back to the previous. Uh, uh, situation your VM was present in before performing malware analysis. At that point of time, it was not infected as much, and you can again start working on it the way you were working previously. So it is actually creating an entire a simple environment for you for performing malware analysis. You can create a VM for performing malware analysis, just and another VM you can create which can run as a victim machine where you will be running those malwares, or you may use just one machine. Anything you may do anything as required, but it is recommended not to perform all these things in your host machine. Sandbox environment is also similar kind of environment, but it is provided with all kinds of tools. Even in VM, if you have a specific VM for malware analysis, it does have all the tools installed. Like Remnux has, Flare VM has. They have all the tools installed. You can directly install those VMs into your system or those sandbox environment. They are made only for performing malware analysis. So instead of creating or setting up a lab all by yourself, you can use these things. You can use these VMs, you can use this sandbox environment. And this may just reduce your, time, and you may focus on the analysis part. And make sure your host machine has a minimum of 8 GB RAM. It actually helps so that your system, your analysis would work very smoothly. We'll see some demo examples that I had performed previously. So as I had mentioned about WannaCry virus, WannaCry ransomware. So I uploaded that particular file into virus total, and here you can see that most of the 56 out of 61 these scanners or anti-malware scanners have detected that it is suspicious or this is malware. 56 security vendors and 5 sandboxes flag this as malicious. So from here we can be very sure that yes, this is a malicious software. It often gives you a lot of details like what kind of malware it could be. Like is it a ransomware? Is it a Trojan? Is it a worm? And it also tells you what the name of this particular malware could be. What is their behavior? What the relations could be, when it was first created, or it was what was the first when was the first time it started infecting different organizations or devices. This is the image of different strings. Here you cannot see anything readable. Let me move on to the next slide. Here you can see that when you're trying to analyze different strings that have been used, you can see there are some processes, there are some functions that have been used. So these help you to detect that what kind of functionality that particular program is trying to perform. Is it necessary for any program to perform such activity? Because there are some functions that most of the programs may not use, some specific programs might use, and they are not required. These are some other examples of strings that we saw. Even we saw WannaCry written over there. So we could be more sure that, okay, this is performing something. We can see that there's write file. It is calling some DLL like kernel32.dll. This is this is one of the DLL file, which is used by almost all the programs. So we can see some other kind of DLLs also, like adwap i32.dll, some function calls that it is trying to make. There's some other details that we can see, like PE32 is giving you an idea about that it is portable, executable for 32-bit. So these are some kind of information that you analyze. This is just static analysis that I have performed, and I came to know about all these kinds of things. Later, dynamic analysis would help you to connect those dots. I have not given any screenshot for dynamic analysis. These are just for static analysis. As a beginner, you can start always with static analysis. Once you are well versed with analyzing and ob- observing these kinds of details, you can easily move on to dynamic analysis. So there's some other information, what kind of information we can see. All these things are, important. We have to, not all of them are important, but they help you. Like, you'll have to analyze, you'll have to observe, you'll have to have patience to, understand how to analyze only those information and understand which of the information is actually necessary. There's some more DLL files, some more strings. Yeah. So some real world examples that I would like to talk about is Stuxnet. This was one malware which was used for, I think, preventing some kind of nuclear war. We don't have to get into too much details, but these are very famous malware attacks that have happened previously. Petya is one. I love you is another one. This was spread through emails, and people would actually open this. There was an attachment. People would open those attachment, and it would end up disrupting, infecting their system basically. WannaCry is a ransomware. These are some very famous attacks. Stuxnet, Petya, WannaCry. We have actually heard about these kinds of attacks. Melissa is one. Pegasus is one. Very, very recent. People keep talking about all these kinds of examples. So these are very famous attacks, and their analysis is also present. You can search about their analysis. You can find how some organizations or some groups have analyzed how what was the intention behind this malware, these kinds of attacks. So some prevention. Even while discussing about analyzing malware, we did discuss what we should not be doing. We should always install some anti-malware software. It is recommended. Of course, nothing is 100% secure. Installing an anti-malware software does not guarantee that your system will never get infected, but at least you can protect your system to a certain extent. Perform regular security checks. It is very necessary. Your system a lot of times keeps asking for performing regular updates. They also patch if there is any kind of vulnerability present, so it is very important to update, perform security checks. If you're using your office's laptop, they perform some kind of patching on a regular basis, perform security checks, and they should be, in fact, doing this. Avoid clicking any unknown links. You may have no idea about what the link could be about. Just don't click it. It's very important. We don't have to click on every link. If you find it very suspicious, don't click on it. Keep your system up to date. As I mentioned, that is very important to update all your devices. It is very important because they provide an update to a previous problem, to a problem that was present in the previous version. So it is important that you keep your system up to date. A lot of time these attacks, these malware attacks, actually not all, most of the time, um, most, in fact all of the time, as I have observed, they focus on some kind of vulnerabilities, and of course they would be doing that. So they would focus on some kind of vulnerabilities that are present in the system, and the system is not updated yet, and hence it gets infected. You may look for these kinds of attacks over there, like how some kind of CVEs or some kind of vulnerabilities that they have exploited while performing these attacks. And last, do not trust everything. You cannot trust on each and everything. You don't have to give out your details. You don't need to click on any link that you're not aware of. Always analyze, look twice thrice at whether at what you are clicking on, what you are trying to download. Make sure you read the reviews. A lot of times we end up installing softwares that we are not aware of from the Play Store. Read the reviews, try to understand what is it all about. You may figure out something. It is not necessary for you to always perform the technical analysis part, but a simple analysis or simply being aware of what you are clicking on, what you are going through, what you are watching is very important. And conclusion, finally, not last but not the least, you can gain a lot of information from simple static analysis. As I mentioned, like the static analysis, when you are using proper tools, when you are using proper mechanisms, proper techniques, you would gain a lot and lot of information from static analysis. Dynamic analysis would help you in connecting those dots which you must have missed, and of course you would gain more information, but the static part gives you really a lot of information. The next line, next point has also been mentioned by me right now. Like this gives you an idea about how to go ahead with the dynamic analysis part. It is important to use a virtual or sandbox environment. It is always recommended. Do not perform any kind of analysis on your actual machine. Also, while performing, it is not very possible for you to perform them because you need to remove a lot of security features, and it is not recommended to do so. Do so in your host system. So, if you are performing that in your virtual machine or in the sandbox environment, no issue. And last but not the least, again, have patience because this is just the beginning. It will take a lot of time. Analyzing a malware will take a lot of patience. You will have to have a good observation skills. You'll have to keep observing. With experience, with practice, you'll learn a lot and you'll keep learning. So keep learning, exploring, and you can reach out to me, my LinkedIn profile, through my Twitter handle. If you have any doubt, if you have any question, you can always reach out to me. And thank you so much. Thank you, Techno Day, for giving me this opportunity. And happy Women's Day, everyone.